Mr. B. Dhanasegar is working as a lecturer in Department of Information Technology, Anna University, Chennai. He finished his MCA from Urumu Dhanalakshmi College, Bharatidasan University. He finished his ME in Computer Science and Engineering from College of Engineering, Anna University. His areas of interest are multi-core programming and architecture, programming models, compiler, automata theory, cryptography, and algorithms. He is an expert in subjects like compiler design, formal languages and automata theory, analysis of algorithms. His research area is code generation for multi-core architecture.
Welcome to the UGC lecture series on computer science. So we have the subject compiler design. So in the previous episode we have been studying the derivations. That means given a context-free grammar, that is how we are finding whether a string has been accepted by the grammar or not. So that requires the starting symbol. We will start the derivation from the starting symbol, and in each step of the derivation we will be expanding one variable available in the grammar, that is in the derivation, and as a result of that we will be getting sentential forms. So a sentential form that is part of the derivation will become the last one, provided you are having everything in the terminal form. So as long as we have variables in somewhere in the sentential form, we will be expanding this variable with the help of the appropriate right hand side of the production, so that we will keep on expanding the sentential form, and finally we will get the sentence. So to find whether a string is there in the language of the grammar, we will be using the derivation. The derivations can be of two types. One is the leftmost derivation and the other one is the rightmost derivation. As far as leftmost derivation is concerned, we expand the leftmost variable available in the sentential form to get the next sentential form, whereas in the case of rightmost derivation we will expand the rightmost variable in the sentential form, so that we will be getting the next sentential form of the entire derivation. So the leftmost derivations are used by the top down parsers, and whereas the rightmost derivations are being used by the bottom up parsers. And here we have the topic called that is an ambiguous grammar, and how the ambiguity available in the grammar has been eliminated. So we know that context free grammars are having list of productions, and they will be used for deriving that is sentences from the grammar. And if you are given a sentence and for which exactly only one leftmost derivation or only one rightmost derivation, that is we will be fixing that whether we have to proceed with the leftmost derivation or with the rightmost derivation. So if you know that we are going with the leftmost derivation, if exactly only one leftmost derivation is there, then it means that there is no ambiguity available in the grammar. Or if exactly only one rightmost derivation available for every sentence available in the language of the grammar, then we can say that the grammar is going to be an unambiguous version. So now what will happen is, if you are having more than one leftmost derivation or more than one rightmost derivation, then we will be having difficulties in parsing the sentence or deriving the sentence. So what will happen is, sometimes we will be left with two or more number of choices for a sentence, and we will be unwantedly expanding the sentence. So the parser will be in confusion. To avoid this kind of situations, we will be going for unambiguous versions of the grammars. So now we should know that is what is an ambiguous grammar. So that is any grammar that has more than one leftmost derivation or more than one rightmost derivation for the same sentence. So that will be called as an ambiguous grammar. So to show that when a grammar is ambiguous, it is enough to find out just one sentence which has more than one leftmost derivation or more than one rightmost derivation. But at the same time, if you want to show that a grammar is unambiguous, then we have to find out the entire, that is collection of strings available in the language of the grammar. So we know that most of the time the language of a grammar is going to be infinite if there exists some recursive productions. So in that case, verifying every sentence is certainly not possible. But we can prove the grammar is ambiguous just by picking one sentence which is going to be an ambiguous sentence. A sentence is said to be ambiguous sentence provided it is having more than one leftmost derivation or more than one rightmost derivation. Or otherwise you can explain it with the help of the parse tree. Parse tree is the pictorial representation of the derivations. So, if there exists more than one parse tree for any sentence, then the sentence is called ambiguous sentence and the grammar will be considered as an ambiguous grammar. So, two ways of defining an ambiguous grammar, one with the help of either the leftmost derivation or with the rightmost derivation, and another one with the help of the parse tree. If there exists more than one leftmost derivation or more than one rightmost derivation, the grammar is certainly going to be an ambiguous grammar. Or if there exists more than one parse tree for any sentence, then the grammar is also called as an ambiguous grammar. So, we have difficulties in parsing the sentence provided the grammar is an ambiguous grammar. So, most of the time we will not be able to find out a valid parsing table which will be used for parsing the strings. But now we have even that is some kind of that is compiler writing tools. So, they will be capable of handling with ambiguous grammars with some extra information, there is an additional information we will be providing along with the parser construction. But if you want to that is construct the parsing table without any difficulty or without extra information, then we want to have the grammar be unambiguous, so that the parser will not find any conflict in between shift conflict or shift reduce conflict or reduce conflicts. So, these may be the conflicts existing in your parsing process provided your grammar is an ambiguous grammar. So, we must ensure that the grammar is unambiguous prior to going for the parsing table construction, so that the parsing table will not be having any difficulty in parsing the sentences. So, now we can see that is one ambiguous grammar, here it is given. So, this grammar is the most familiar that is ambiguous grammar, that is an expression grammar. So, which has the productions that is E derives E plus E and E derives E star E, then E derives E exponentiation E, and another one is an expression is enclosed in bracket or it is going to be in symbol identifier. So, this is the grammar we are having that is 5 number of productions. The first one is sum of two expressions, the second one multiplication of 2, the third one exponentiation, and the fourth one is going to be anything within bracket, and the last one is any atomic expression which is going to be an identifier. So, now this grammar is having ambiguity, but to prove this grammar as ambiguity, so we must show that there exists more than one leftmost derivation or more than one rightmost derivation or more than one parse tree for any one of the sentence from this language of this grammar. So, we know that the id plus id star id is going to be a string which is there in the language of this grammar, where id stands for this any identifier, plus and multiplication are the operators for addition and subtraction, that is multiplication respectively. So, now look at the first one, we are starting with the start symbol of the grammar capital E, which is expanded using E plus E, and since it is going to be a leftmost derivation, the first variable to be expanded is this E. So, once this E gets expanded, we will be having that is id here. So, we are having 6 choices for expansion, but if you are going ahead once again with E plus E, we will not be able to derive id plus id star id, and similarly if you go again with E derives that is E star E, then once again we will not be able to get id plus id star id. So, time being we find that the only choice for this E, so that we will be able to get this string, is only identifier, that is id. So, now we find id followed by a plus, then followed by another expression that is going to be a non-terminal, and this time this non-terminal is supposed to be expanded. So, we will be having E multiplied by E, now the expansion is because we want to have an expression with multiplication as operator, and now we are having id plus E star E. So, this is further, there is the next variable to be expanded is this E. Once I am going for expanding this E by id, so we will be having id plus id, and finally this E gets expanded, so we will be having id plus id star id. So, because of we have a derivation from the start symbol of the grammar to the sentence called id plus id star id, we claim that id plus id star id is a string available in the language of this grammar. So next we can have another derivation using the same leftmost derivation concept. So we start with e, and this time instead of that is expanding this e by e plus e, I am expanding this by e star e. So what will happen here is the star becomes the operator, so which forces you to change the order of the application of productions for the first, that is leftmost variable here. The leftmost variable here is capital E, and which cannot be subjected for now an expansion with id. In that case we will not be able to recognize the string called id plus id star id. So we are forced to have the expansion, that is e expanded to e plus e, and then as usual this e gets expanded by id, and then finally there is next step is this e gets expanded by id, and finally this e gets expanded by id. So we will be having id plus id star id. So when you are looking at the derivation, that is both leftmost derivations for the string, we start with the starting symbol of the grammar, that is same thing, and finally we are ending up with that is id plus id star id, the same sentence. But when you are looking at the intermediate steps, that is the intermediate sentential forms, if you look at the sentential form that is at position here, it is e plus e, but here it changes to e star e, and in the third one it is going to be id plus e is the sentential form here in the first derivation, whereas in the second derivation e plus e star e. So even if you are constructing a parse tree, so what will happen is the root is certainly going to have only one symbol, that is your e, and in the first level we will be having 3 nodes, so e plus and e, and here it is going to be e star e. So that itself is showing that the parse trees are going to be different. And when you go for the third level, what will happen is we will be having only once again 3 nodes as far as the first derivation type is concerned, but whereas we will be having around 5 number of nodes as far as the second derivation is concerned. So anyway we find that both the derivations are completely different, but we started with the starting symbol of the grammar and we are ending up with the exact sentence which we want to derive. So which shows that this grammar is an ambiguous grammar. So now the question is, how will you eliminate the ambiguity available in the grammar? So to eliminate the ambiguity available in your grammar, so actually there is no algorithm for the elimination of ambiguity available in any grammar, but it is possible to eliminate for most of the grammars, most of the ambiguous grammars, provided we know what is the reason for the ambiguity in this grammar. But there are grammars for which the ambiguity cannot be completely eliminated, and such type of grammars are called inherently ambiguous grammars. But here we are talking about only the removal of ambiguity from a grammar because it is possible for us. So here the reason for the ambiguity is, you can think about the derivation that was shown earlier. So here we are having the expansion with the plus, and here we are having the expansion with the multiplication. It means we do not have any rule about what is the priority and what is the associativity for the various operators available in the grammar. That is, all the operators are taking equal priority, and all of them can be used with either with the left to right associativity or with the right to left associativity. Since the priority and associativity information are not included in the grammar, we have the ambiguity being produced. So that is what we are saying, the usual priority and associativity of the operators, that is plus, multiplication and exponentiation in the grammar are not considered. So actually this is introducing equal priority for all operators, and moreover the associativity information are also not properly mentioned. So we will be assuming that all the operators are having equal priority, and the associativity can be either left to right or from right to left. So this is what the reason for the ambiguity available in the grammar. Now the question is, how this ambiguity available in the grammar can be that is eliminated. So we know that without eliminating the ambiguity available in the grammar, it is not possible to go for constructing a successful parsing table, so that the parsing table can be used for parsing the sentence. So now what we should do is rewrite the productions with the priority and associativity that is being incorporated into the grammar. So that is what the idea of finding the unambiguous equivalent of an ambiguous grammar. So first you find out the priority and associativity information for the operators available in the grammar, So we know that the usual priority of operators is plus takes lower priority and then multiplication if it is going to be the arithmetic cases, and then it is going to be exponentiation, and then finally we will go for any expression within the bracket. So we shall go for a short break and then we will continue the lecture. Welcome back. So we have seen the priority and associativity of the operators. So plus is taking lowest priority and then multiplication takes next priority, and the next one is going to be the exponentiation. So as far as these three are concerned, and we know that plus and minus takes same priority, and similarly multiplication and division takes same priority. And with respect to associativity, plus multiplication, subtraction and division, so they are all supposed to be evaluated from left to right. See, for example, if you are having a plus b plus c, then first you compute a plus b, then you can go for computing the sum of a plus b with c. But you should not change the order that b plus c will be computed first and a will be computed next. So it may look same result, or it may seems that both will give same results as far as the expressions are concerned, but that is not guaranteed always. Maybe because of some kind of side effects, maybe a is going to be a reference variable, or a is having alias, something like that. In that case, so if you are changing the order of the evaluation of the expression, then there will be different results being produced as a result of that. So we must strictly follow the uniform rule that plus, multiplication, subtraction and division, that is all the four must follow the left to right associativity. But whereas the exponentiation is concerned, so we must follow the right to left associativity, which means that if you are having an expression like a to the power b to the power c, then before completing a to the power b, we must have completed b to the power c. So the result of b to the power c will be considered for taking the exponent of, that is, a. So the order of evaluation of exponentiation is strictly from right to left. So first we must know the priorities of the operators, and then we must know the associativity of the various operators, and if these two things are included into the grammar, then automatically your grammar will become an unambiguous grammar. So as far as this particular example grammar is concerned, that is your expression grammar, so we will be having that is productions e derives a plus t, so e derives e plus e, then e star e, then e to the power e, and that is expression within the bracket. These are the productions available. So now look at the productions being written, that is as a result of the ambiguity removal. So we will be having the productions. For example, if I am having, that is the last one, we say that is f derives open bracket e closing bracket or id. So this will be considered as the highest operator, that is precedence, that is operation. Whenever we find that is some expression inside bracket, we will give importance, or we will give priority for that expression, so that that expression gets evaluated first, and then we will think about the adjacent operations. So that is what it is being included here. So the productions are actually written in the increasing order of the productions. So the maximum priority is given for an expression inside bracket, and the next one is given for exponentiation, and the next lower priority is given for multiplication, and finally it is given for addition. So here we have the productions, that is e derives e plus t, and another one is called t. So this is actually being introduced for that is relating the various operators along with the start symbol of the grammar. And another important thing here we have to understand is, so we find here there is e plus t and t star p. In both cases, the leftmost variable is going to be the one from the left hand side of the production, but whereas when you go for exponentiation, we find we are having still the left hand side of the production being used on the right hand side also, but it is not on the leftmost position, but it is here, it is on the rightmost position. So that is, we find two different ways of writing the productions with the connection. So one is e derives e plus t and t derives t star p, and the another one is p derives f to the power p, where p is on the right side rather than the left side. So, if you want to follow the left to right associativity, then the left hand side of the variable must be available on the leftmost end of the right hand side, as in the case E derives E plus T and T derives T star P. But whereas if you want to maintain the right to left associativity, then we should go for placing the left hand side of the variable on the rightmost end of the right hand side. So, we have f to the power that is p there. So, that is the reason why we find two classes of productions, the two methods of writing the productions. And as far as this T, P and F are all concerned, they will be used for connecting the various productions. And because of this T on the right hand side, and that is your as far as this production is concerned, we ensure that the associativity is from left to right, and here also the associativity is from left to right, and here the associativity is from right to left because of the P is on the right. And the next one, as far as the priorities are concerned, when we are having A plus B and multiplied by C, so we should know that the multiplication must be carried out first, so that we will go for adding doing the sum. So, if you want to have that kind of situation, we must go for writing the productions in this way only, that is E derives E plus T or T, then T can be expanded to T star F, but not that that is plus first. So, we will be computing multiplication first and then we will go for computing addition. And if you are having exponentiation also, we will go for doing exponentiation first and then we will go for carrying out multiplication, and then we will go for carrying out this addition, and this would the order of that is the evaluation of the various operations, that is if you are having different operations like this. And if you are having same operator like A plus B plus C plus D plus something like that, then the associativity is going to, because they are all going to have the same priority, the associativity matters. So, in that case if you are having same operator, then the associativity will be ensured, so that if you have A plus B plus C, then the computation will be A plus B followed by that is C. So, this grammar is going to be an unambiguous equivalent grammar for the expression grammar with there is 3 number of operators. One is the addition, and the next one is multiplication, and the final one is going to be the exponentiation. So, this is one important grammar for which the ambiguity can be that is eliminated. And the next one is we are having another grammar called the dangling else grammar. The dangling else grammar is the one which is being used for describing the syntax of any if statement. So, if statement has the syntax like if, a condition, then a statement, else, another statement. So, that is the statement syntax if you are having both the then part and else part. But it is not sure that always we must have both then part and else part. Sometimes we may just stop with the then part alone, and there may not be an that is else part. But if you find that both then part and else part are available always in all the if statements, we will not be having any issue. But when you have nested ifs, that is if statement as part of another if statement, if some of the if statements are having the then parts alone and some of them are having both then part and else part, then there will be a confusion because of the else's. That is, we will be having more number of then components, but lesser number of the else components. So, if you have lesser number of else components, and with what then the else's are to be associated, that is a question. So, if you are always having equal number of then components and else components, we will never be having any that is issue, because every then part will be having else part. But if you are having more number of then components, but lesser number of else components, the issue will be with what then a particular else is to be associated. So, this is going to be the problem called dangling else. So, if the grammar is not properly written, then we will be having this dangling else problem, so that some kind of unexpected behavior may happen as far as the execution of the code of the program code is concerned. So, we will go for the grammar is given here. We have S derives if, condition, then statement, that is having only then part. Another one is if, condition, then statement, else statement, which is having both then part and the else part, and it can be any other statement. So, it is not necessary that always we must have only if statement, it can even be any other statement. So, the any other statement, it can be an assignment statement or it can be a while statement. So, we will not be facing problem due to the else as far as these cases are concerned. We have problem only with these first two cases. So, now we must go for rewriting this grammar. So, for the rewriting of the grammar, we first of all understand what is the reason for that. The reason is because of this else. So, if I am having always then part and else part, we will be having a match statement. Match statement means every then has a matched else. But if you are having only then part, then it will be a statement which is an unmatched statement, which means that this particular statement will not be having an else. But when you combine these two, so there may be something like if condition then. So, within this yes, there may be a statement called if condition then statement else statement, and maybe the outer one we may not have a else part. So, in that kind of situation, associating the else with what if, that is going to be the issue. So, now for removing the ambiguity available in this grammar, already we have seen what is the reason for the ambiguity available in the grammar. It is because of lesser number of else statements available when you are comparing with then, there is dangling else. So, we need to classify the grammar into there is two sets of productions. One is meant for recognizing only the matched statements. Match statement means that for every then there will be corresponding else, and there will be another one class of statements, that is productions that are meant for unmatched statements. Unmatched statement means if there is a then and there won't be any else, that will be considered as an unmatched statement. So, if you group them into matched statements and unmatched statements, then the ambiguity available in the problem, that is grammar, will be completely eliminated. That is the problems raised because of this else will be completely removed out of this grammar. So, that is the reason we have the new set of productions. S is deriving M or U, that means the matched statements, and another one is going to be the unmatched statement. And the matched statements could be either if, condition, then, and we must have a match statement here, and else we must have another match statement here. So, we cannot make any one of them, even one of them, as unmatched statement. So, if you are replacing this M by U, then once again the entire statement becomes an ambiguous statement, or even here also, if it is going to be a unmatched statement, the whole statement will become an unmatched, that is your ambiguous statement. So, we must have both then part and else part as any match statement. It can once again be an if statement, or it can even be any other statement. So, that is not an issue, but we must ensure that it must be a match statement, whether it is if or any other. Then when you are going for writing this unmatched statement, and we find that the statement is not going to have an else as such, but what happens is the if, condition, then. So, this is expected to be there is a match statement. So, only because of this the whole statement's ambiguity has been resolved. Here in the match statement there may be then and else. Since we are having else for every then part in the match statement, there is no pending else, and it won't create any issue with this then. So, we are always knowing that this then has no else component, but it is only having the then component only, but not else component. This one thing. And another one is, so how do you handle the unmatched statements which are having else component? So, here the issue is we are having if component, then the condition, then in between then and else we want to have always a match statement. So, the advantage here is, since we are having a match statement in between the then and else, so this else will never be a problem for us. So, if you are introducing an unmatched statement here, then there will be an issue because of this else. So, to avoid the problem we are facing with else, there is dangling else, we must introduce a match statement in between then and else, and followed by this else we may even have an unmatched statement. So, because of this unmatched statement, anyway we know that it is not having the else component, we have only unmatched, that is the then component. So, this entire productions will give you the new grammar which has no ambiguity as far as the dangling else grammar is concerned. So, we must rewrite the grammar meant for that is your dangling else grammar, so that the ambiguity available in this will be completely eliminated. So, to summarize, so the ambiguity is because of more than one parse tree or more than one sentence, parse tree for any sentence, and or more than one, that is leftmost derivation or more than one rightmost derivation, and the ambiguity can be removed in most of the cases. So, we will be removing after identifying the there is a reason for the ambiguity by rewriting the grammar, so that the grammar ambiguity can be eliminated and thus the parsing table can be constructed. So, regarding the questions, what is the meaning of ambiguous sentence, the definition of ambiguous grammar. So, example for ambiguous grammar, how will there is ambiguity available in the expression grammar or it is going to be eliminated, and eliminate the ambiguity available in Danglingen's grammar. So, even there are different grammars where there are having ambiguity, and we must find out first of all the reason for the ambiguity, and then we can go for appropriately rewriting the grammar, so that the ambiguity available in this grammar could be eliminated. So, that is about the ambiguity and the removal of ambiguity. Thank you all.